Hi there, this is Jacob Nash, Pre-Calculus Lessons, and this is a video about how to solve trigonometric equations. And this, I'm pretty sure is the last video of my pre-calculus videos. Seems like I got through these quicker than the other 3 courses that I've done. But I guess not. I mean, I started, the first video for pre-calculus was in August, so maybe not. So no intro today, no like that intro noise, because I have to record with my phone because, of course, every possible recording thing is messed up. Can't use my computer right now, can't use iPad that I've been using. Can't use that, don't want to crack the screen. And then this camera that I've used for a couple ones is dead, so I have to use my phone that uses a lot of storage, and that's annoying. That's the only thing I can do. So, I'll try to draw it on here. That's kind of hard to do, but get the cap off of this. So, I will say, we're assuming, and usually you want to do angles that are in radians. So, it's good to know your unit circle. But let's assume that we have our angles that are going to be in between 0 and 2 pi, which, if you know, that means 0... kind of hard to draw with one hand. 0 to 360 degrees. So that's what we're assuming. And the first thing that you want to do is isolate. You want to isolate the trig function. So just like how you would isolate x, you have to make it by itself. Then you want to figure out quadrants, what quadrants it's in, because you could have up to 4 different angles based on if it's negative and positive. Remember the rule? I'll go over it real quick, but based on the quadrants, if this is quadrant 1, this is 2, 3, this is 4. Here, all are positive. Here, sine and cosecant are positive. Here, tangent and cotangent are positive. And here, cosine and secant are positive. And obviously, where they're not positive, they're negative. So, for example, here, tan cotangent, cosine and secant are negative in this quadrant. And you can remember that by all students take calculus, ASTC. And just remember that the reciprocal is also positive there. So let me erase that. Gotta get an eraser. And so that was just a review, but I already talked about that. Yeah, that was the last unit anyways. So once you figure out what quadrant it's in, then figure out the sides. Then you figure out the angles. So that's really the steps. So let's start out with a simpler one. So cosine of angle equals negative square root 2 over 2. So first thing is to isolate the trig function. That means whatever trig function you see, which is cosine in this case, make it by itself. Well, it already is. You don't worry about the angle. That's just a part of it. So don't try to get rid of the angle or something. Then quadrants. Okay, so if we know all students take calculus, I always draw this little thing right here. And since cosine is negative, we'll cross out we could just circle which ones is a negative in. It's obviously not negative where they're all positive. It is negative in this one, and it's negative in this one because we know it's positive in those, so it's negative in those. So our quadrants where we'll draw our triangles to find our sides will be in those quadrants. So let's go ahead and do that. And remember, this is not going to review right now about how to do the triangles, but it's understood that these two angle lengths would be the same. But we have to find the angles. That's what we're trying to do. But we can't find it until we know what the side length is. Well, cosine is x. Remember, cosine x sine y. And then tangent is y over x. So cosine is x, so that means the x side is, what do you know? Square root of 2 over 2. So this part right here is that. And that makes sense. It would be negative, obviously, because x is negative over here. But we need to find out this. We always have to know the side across from the angle. That's what we want to always know. And that's y. So that's why it's sometimes a little bit trickier when you get cosine, because it doesn't tell you what side's opposite of it, because that's always going to be the y. So we're trying to know what else it would be, but by our perfect triangles rules, we would know that this would be square root of 3 over 2. And it would be negative down there. And by our rules that we learned from the last unit, across from what angle is the square root of 3 over 2 across from? A 60-degree angle. Oh, wait. Sorry, I completely did that wrong. That would be if it's 1/2. Sorry, that's completely wrong. Sorry. Wrong. Sorry. By our perfect triangle rules, we would know that across from that would also be square root of 2 over 2, because the triangles that we know, to review, are square root of 2 over 2, square root of 2 over 2, 1, obviously, because we want to have 1 as our hypotenuse, or it would be a unit circle. And then the other one that we know is this, and that was the one that I got mixed up with. But across from these angles, we know is 45. Or sorry, 45 is across from a 45-degree angle is these. That's what we learned from the last one, remember? Doing a little quick review here, but across from that one is 45. Across from square root of 3 over 2 is 60. Across from 1/2 is 30. That's what ones we need to know. Remember those? So that means our angles are 45 degrees. Kind of messed this up a little bit. So let's erase a few things. So our angles are 45, 45, and by our other rules we know, if there's a 45-degree angle, there will be a denominator of 4. If there's a 30-degree angle, we'll have a denominator of 6. If we have a 60-degree angle, denominator is 3. Okay, well, since we have 45-degree angle, we'll have a denominator of 4. And there's going to be 2 angles, as we can see, 2. And so our angle is going to be 2 different things, and we know the denominators have to be 4. And since it's in radians, there's got to be a pi on it. But knowing our unit circle, which I'm not going to review right now, but the second quadrant, it's always 1 less than the denominator, and then the third quadrant is always 1 more. So there you go. That's the angles. And of course, those were the steps we did, and that took a little bit long because I was explaining it. I went through a lot of review, which I thought that was a good thing to do just in case you didn't remember. So that one, unfortunately, if you thought that was hard, was considered one of the easier ones. But because there's a little bit, remember, we didn't even have to isolate anything. So let's do another one where it's a little bit more complicated. Sometimes you have to even factor. All right. I'm going to do, and you sometimes have to use your Pythagorean identities too. But I don't know if I'll have time to do that in here, because that's just a review. You should know how to apply it all. But let's see, which one can I do? Trying to find one where you factor. I don't, man, that's weird. Oh, well, I could try to make up one, but then it might not work out. Well, here, let's just do this one real quick, okay? How about 4 secant squared x, x can be angle, just so you know, equals 8. Okay, there we go. Sorry that it took a long time for me to do this. All right, what do? Well, we have to isolate the function, that secant. We have to get it by itself. That includes no more squared, too. So, first, knowing our PEMDAS rules, well, this not necessarily our PEMDAS rules, but just imagine if this was 4x squared equals 8. What would you do to get x by itself? That's what you can do, because secant x is basically just x, if you think about it. So, what if you know your rules, then we would divide by 4 first. Now, we take the, well, let's actually make this cosine, because we know that's the reciprocal. And it's always 1 over secant equals cosine. So we'll change that 2 to 1/2, because it's 1 over what it was. 1 over 2, 1/2. Okay, we still have that squared there. We have to take square root. So secant of x equals negative and positive square root of 2. Don't just do positive square root of 2, because it's negative or positive. So now, quadrants. All students take calculus. Is it negative or positive? Well, both. So that every single quadrant is going to be it. So we have 4 angles this time, we already know. So we'll draw 4 different triangles. And remember, I said if you did it right, it should always look like a butterfly, sort of. And the angles should be the same measure, but we need to figure out what they are. So, oh, sorry, I forgot to change this to cosine, because we did 1 over 2. Sorry about that. Forgot to change that. Okay, so cosine, once again, is x, so this is a one that's kind of annoying. And 1 over square root of 1/2. Well, what? You might say, I don't even know what that is. That's not one of the things, because you might be thinking, I only know 1/2, that, and that. Well, they wouldn't give you the problem if you couldn't do it, because that wouldn't be a unit circle. So obviously, it has to be one of these. Well, would square root of 1/2 be the same thing as just 1/2? No, obviously not. But if you think about it, we can. What's the square root of 1? Because if we're taking the square root of 1/2, our radical rules tell us that it's this. Square root of 1 is just 1, and then this square root of 2 can't really do that. But if we tried to make a radical not in a denominator, that would change to square root of 2. Square root of 2 times square root of 2 is just 2. Oh, there you go. Now we know what it is. And it's just like the other example we did. If x, that would mean x is that, but also y is that by our perfect square rules. And I'm not going to take the time to write it, but because it's the same for all of them, except for just negative down there. And we know 45 is what the angle would be, by what I already told you. And so there's going to be 4 angles. X equals 4 different ones. What do we know? Since it's 45-degree angle, denominator is 4 in all of them. There's going to be pi in the numerator of all of them, since it's in radians. And now we just have to figure out the other numbers in the numerator. Well, anything in quadrant 1 already only has pi there, so that's one of them. 1 less than denominator, 1 more. And then 1 less than twice. So 4 times 2 is 8, minus 1 is 7. And eventually those numbers you'll just remember because you do it so much. And that's that example. Let's just do one more before the video ends. So, I'm looking at my paper here. There's some notes. How about, ooh, I see one that's a little tricky. Let's do this one. Okay, I'm writing it, then I'll show the camera. So we didn't have to factor in any of them yet, but we know how to factor this one. Well, we'll see. Oh, that doesn't look so fun. Why? Well, because there's two different things in it. So you can't, which one do you isolate? Well, you can't isolate anything yet, so there's sort of like a additional step before one sometimes that you have to do. Well, you always have to think. They wouldn't give you the problem if you couldn't do it, so what do you know? Well, we know that there's Pythagorean identities. We learned those. So how about we try to see if that works? Sine squared x. Oh yeah, remember that we have this. That's one of the Pythagorean identities we know, and if we were trying to get that by itself, you would subtract that, so it would be 1 minus cosine squared x is the same thing as that. So we can replace that with this. Alright, and now that's a little bit better, and now we're going to have to isolate the cosine. But we'll have to factor because there's two different cosine things. Let's get everything on one side, because when we factor, you know it has to be set to equal to 0. We can add cosine squared x, and then plus 2 cosine x. Then we have a plus 2. To get that on the other side, we would subtract 1, so 2 minus 1 plus 1 equals 0. Oh, well, you might think, how do you factor this? Well, like I said, it's really just this. That's really all it is. You can just replace the cosine x with x, and then you might know how to do it. So that's all it is. So what two things multiplied equal 1 to add to equal 2? So cosine x plus 1. Oh yeah, it's just the same thing for both. Because 1 plus 1 is 2, 1 times 1 is 1. That's how we know we did it right. Alright, now we have to set both of those things equal to 0 separately, but it's the same thing, so luckily we only have to do that once. And now that's starting to look more like the problems we've done before, but we have to get cosine by itself, so we'll do cosine x equals -1. Alright, well, -1. What quadrants would that be in? Well, -1, you can already tell that's a quadrantal thing. Anytime it's -1, 1, or 0, it's a quadrantal angle. And what that means is that it's going to be 0, 90, 180, or 270. Or 0, pi over 2, pi, 3 pi over 2. And also 2 pi, technically, if you count that as 360 degrees, whatever. So that's what we know. And if you think about it, if you were to draw your quadrants, the point here is 1, 0. Point here is 0, 1. Point here is -1, 0. Point here is 0, -1. Cosine is x. We know that. X equals -1. Where is x -1? Not there. Not there. Oh, there. So that means this is where our angle is, and it's only one angle because -1 only is in one place. So anytime you have a quadrantal angle, the only case that it would be 2 is if you had 0 cosine x equals 0, because there's 2 zeros for x, but it's -1. See, -1. Cosine is x. There we go. And if you know this is 180 degrees, what is that in radians? Pi. So x equals pi. Wow. Start out complicated, ended with just a simple answer. And that is how you do it. So these are the steps that you do, but you need to remember a lot of different things I talked about, the Pythagorean identities, but you sometimes have to factor. You have to use Pythag identities, or reciprocal functions. Remember, because we had secant in the other one. And if you take the square root, that means it's going to be in all quadrants. And also, remember your quadrantal angles. So anytime you end up with -1, 1, or 0, do this thing and figure out what it is. Cosine x, sine y. And there are some more complicated ones, like tangent. I'm just going to say that real quick so I don't leave that out. I know this has been a long video already. But in the case that you would get tangent x equals -1, that isn't a quadrantal angle, because you have to think what could get -1, because you're kind of doing it backwards of what we did before when we were finding the sides, or we were finding this thing. You weren't finding the angle. And technically you could do tangent of -1 to figure it out, but not doing a calculator, you wouldn't be able to do that. But if you think about it, if you had this, we know that's what would get you to that. And there isn't there a, and if this was your y and this was your x, because tangent is y divided by x, so that's the only thing that could work if you had -1. And then if you had tangent is square root of 3 over 3, you would know it would be 1/2 and square root of 3 over 2. That was pretty brief that I just said, but you might need to look into that a little bit more if you want to review that. But tangent's a little bit more difficult, but you just have to backtrack and do the reverse thinking, like how could you get -1? Well, your only possible triangles are square root of 2 over 2 or square root of 3 over 2 and 1/2, 1. So that is basically how you solve trigonometric equations, and it's a little bit tough, but that's it for this video. Thanks for watching, and if this is the last pre-calculus video, thanks for watching these videos if you did.